welcome to Engineered to Ask, brought to you by the College of Engineering at the University of Nevada, Reno. This is your host, Anthony Kuhl, and with me today is Dr. Zhan Tian, Professor of Civil Engineering here in our Civil and Environmental Engineering Department. Thank you for joining us on the podcast today, Professor. How are you doing?
Pretty good. Thank you, Anthony. I'm glad to be here.
So today we're going to dive into the world of transportation technology. And Dr. Tian is going to help us get a better understanding of what sort of work can be done in this field. But before we get into our main topic today, why don't you tell us a little bit about yourself and what brought you to the field of engineering in the first place?
Well, I've been working in this field for the past, I would say, 35, 40 years.
Oh, wow.
So yeah, transportation has been my major. The reason I'm interested in this field is transportation is truly interdisciplinary field. So people with every kind of background can actually study and work in this field.
Oh, really?
We have students, even with journalism degree, they could pursue a master degree in transportation because, like I said, transportation involves technology. Also, there's a policy side, the policy and the planning. So you don't have to be super good in math. You can still do part of this transportation.
Actually, I think that leads nicely into our question about what sort of work should people be investing in? If they're looking to get into this field, what sort of things should they be looking at with their education or their research in order to be a part of transportation engineering?
Well, usually people with background of engineering, right, technology, any field of engineering will fit this field very well. But as I said, people with a strong math, even if you are good in writing, so you can pursue transportation planning, the planning side of this field. So in general, like I said, people with all kinds of background can pursue a degree in transportation.
So actually building off from that, what does the interaction look like between those involved with the planning side of things and the construction side?
Yeah, good question. For a transportation agency, usually they have different departments. Like planning is one of them, engineering is another. So we do work very closely. The planning, because we try to plan for the future. So in 20 years, how the road network should look like, right? So that's the planning side. But the near term, then we have to design the road. So that's the engineering side. So we do work very closely.
Interesting. Now, from what I understand, you have quite a bit of experience in this background, the 30 years and all. So what is your opinion on the current state of things when it comes to the area of transportation, engineering, and technology? Any recent breakthroughs that you know of that you think are exciting?
Yeah, definitely. Just like any other technology, transportation has advanced significantly over the past few years. So in particular, so we have a lot of data. Usually, whenever we design something or we change something in the operations, we have to evaluate how effective that change would be. So now we have a lot of data automatically gathered, particularly vehicle related. In my particular field, so I work on traffic signals, right?
Oh, interesting.
So we optimize the signal system. How do we know if we have done a good job or not? So previously, we have just go there to manually do the runs. So you take a drive, you collect a few number of runs, and then you make a comparison before after. But now all these data are automatically gathered.
Oh, really? That's so interesting that you had to do like actual manual runs of the streets. That's interesting.
It's called vehicle telematics. So all the newer vehicles, in fact, they embed a GPS unit in it. So whenever you start the engine, they start to know your location and the time. That's how we automatically gather, thousands of vehicles every day. So it's a lot more sample. So we use that to evaluate the performance of a transportation system.
I can imagine having all that data must make it easier to monitor the flow of traffic and where congestion might be occurring.
Exactly. Yeah, a lot of things were done before manually, such as collecting volumes, collecting the delay. Now, because these data are coming from real vehicles, so there's a way to automatically gather them. So I think that's one thing that has changed the way how we work on transportation, change yeah, significantly. Give you a few examples, right? Um, Whenever there's a new construction, as part of the process, we need to study the impact of this new development. And then we need to analyze the intersections of freeways. And then the first thing we used to do is go there to count the cars. So you use a counter, count during the peak hour how many vehicles turning left, how many vehicles going through, how many vehicles going right. So once you gather the volume, you put it into the model and you perform the analysis. So the model will tell you, okay, do we need to add another lane? Do we need to change from stop sign to signal? So these were done before manually, as I said, right? All the data collection. So now at least the data collection, we can gather those automatically from either cameras or from vehicle telematics, as I mentioned earlier. So this will significantly reduce the cost and the time. Another example I mentioned, so that's my field, working on signals. Yeah. So signal timing, every agency spends a lot of money every year to try to optimize the signals so that we can reduce the number of stops and reduce your travel time. Because travel time easily tied to money, right? Time is money. So to evaluate the performance of a signal system, as I mentioned, now we can gather automatically these hundreds of thousands of vehicle runs and to provide a fair before-after comparison. We can also identify where there's a problem. For example, during the construction, a lot of traffic will divert from the freeway to the local road. So in that case, if we don't adjust our signal timing, and then the road will get gridlock, right? So these kind of special situations, we have to actively monitor the traffic and also adjust the signal timing. So we use this kind of data, this kind of technology very frequently in our actual studies.
We have a lot of research on traffic signals here, don't we?
Yeah, traffic signal is combines all different kinds of technologies. You think about it, the optimization is actually you need a strong math background.
Oh, really?
Yeah, but also you have to somehow develop a software tools for engineers to use, right? Then you need programming skills, it's computer science. And then you go to the traffic signal, it's all electronics. And then you think about also drivers' safety, just safety and how can we, if you have a transit, how can we make transit vehicles to go through, with minimum stops? So it combines all kinds of technologies.
It sounds like you have a really large pool of interdisciplinary fields really coming together here. You have like mechanical engineers developing the actual traffic signals themselves. Maybe you have the electrical engineers developing the internal hardware systems, the software engineers developing the back end for the traffic system to work. I mean, this is all fascinating. It's just like a great web of engineering interests all coming together.
You're absolutely correct. That's why I thought this is a fascinating field. Plus, traffic signal is one of the most important elements of a transportation system. Yeah, the one fascinating fact about working in traffic signal system is that you can immediately see the difference. You just simply make some timing change. You don't have to invest in any construction and anything and new equipment. You can immediately see the difference. An intersection could be very congested, but by adjusting the timing, you can resolve those vehicle queues and significantly reduce the delays and the stops if you go along the arterial. So this is why I'm also so interested into this, because I can see the impact. I spend a day. I have done this for many different agencies. So I spend a day and change their signal timing, do a before after. You immediately see the difference. So you can imagine going through Sparks Boulevard as an example, local here, right?
Yeah.
So we did a retiming, so we can reduce in one direction, reduce the travel time by 2 minutes. But there are almost like 50,000 cars going through that corridor. So you convert that every car you reduce by 1 minute or 2 minutes. You calculate per day, how many vehicle hours. And then vehicle hours, that means the time you spend unnecessarily on the road. So we have a value tied to the time,
Of course.
right? Like there's a general number there. In fact, the value is about $11 to $17, depending on the location, per hour. So you convert everything plus the fuel savings is easily it's like 1.5 to $2 million annually, annual saving.
So there is something of a financial incentive both for the driver and the city itself here.
It is, yes. So for a typical driver, they may not feel it, right? If you think, oh, you saved me 2 minutes, they don't think about it, but you accumulate over many, many drivers, and then day after day. So that is significant. I know, yeah. If you're as an individual driver, you don't think about it, right?
Yeah.
You get stuck in traffic, you think it's normal, but once you see the difference, of course you feel, oh, now it's moving a lot smoother than before. But still, you don't think about how much it's saving me every year. So if I can save you, let's say $100 per year, you don't think it's a lot, right? Mm-hmm. But you think about how many people are driving on the road every day. You multiply by that number, and it's millions of dollars.
Wow. Millions of dollars saved every year just from altering traffic signals. I mean, that's amazing.
And that's the time saving. Then plus you reduce the travel time idling on the road. You reduce the number of stops. So another saving is on the fuel. So you reduce the fuel consumption, then you reduce the emissions. So it's also good for the environment. The fuel consumption. So there are models, based on the your speed, the number of stops you made. So there are models to estimate the fuel consumption.
Interesting. And you work within these models to make sure that you hit targeted numbers.
Yeah, there are researchers, they have already developed those models. So the agency usually adopt those models, so they have a standard procedure. Okay, my travel time before is this, after is this. So you see the difference, time savings. Then you look at the fuel savings. So based on the model, you calculate the fuel savings, then convert that into economic figures. And then also, based on that, you calculate the benefit-cost ratio. So benefit cost, these are the benefit numbers, then what's the cost of a real-time traffic lights. So in general, that benefit-cost ratio ranges between 30 to 1 to 400 to 1. That means you spend let's say 400 to 1 means you spend $1, you save $400. Yeah. That's the benefit-cost ratio.
This certainly was an interesting discussion we've had today, that getting to understand this field that not only engineers can find success in, but other majors can too. Thank you so much for being on the podcast today. Do you have any closing thoughts, Doctor? Anything you'd like listeners to know to send off this discussion?
Well, one thing, maybe whoever is listening to this, as I mentioned, with any background, you can come to our program to pursue a master degree. So don't worry, your background is not engineering. So I had a student who had a journalism degree and finished a master degree in transportation. Wow. But to pursue a master degree, you must have a bachelor degree. So that's the key.
That's the key.
Yeah, as long as you have a bachelor degree, even like you with a political science background.
Well, thank you so much again, Doctor, for coming on the podcast today. And a big thank you to everyone who's listening out there. We greatly appreciate you stopping by. If you'd like to know more about how you can get involved with this sort of research and more here at the University of Nevada, Reno, you can visit our website. Links will be in the description. And if you liked this discussion and would like to hear more about other interesting engineering-related topics, please like, comment, and subscribe. It's the easiest way of keeping up with this series and letting us know that we're doing a good job. Until then, this has been Engineered to Ask.